And see your messages. Okay. People. Okay. Okay, so on this one, this is section 12.1. Let me get back to blue. Okay, so this is section 12.1. And it's actually the introduction of limits. So limits at infinity are what we did the other day, but you don't need to know limits at infinity to do section 12.1. So there's no prerequisites. Basically, what you're going to see is you're going to see a problem that looks like the other one, but if you didn't see it, that's okay. Okay, and what you're going to have is you're going to have something like this, X arrow. Okay, so you're going to have a limit, LAM stands for limit, and then underneath it, you have X arrow, and then you're going to have X arrow some number, usually it's not infinity. So let's say we have X arrow 3. Okay, and then what I'm going to make this equation, I'm going to make it a super straightforward equation for right now and just make it 2x so you can kind of see how it works. Okay, there are multiple ways to solve this problem. Okay, there's going to be a very short, easy, beautiful way that we're going to solve it. I also want to show you using a table and using a graph. Okay, so I'm going to show you using a table first because that's what the idea of limits is. This little arrow here, let me point to it with another color for you, but this says approaches. So what they're really asking you is they're trying to ask you if X is getting near 3. Okay, if you're going near 3, what will 2X get near? Okay, so that's the whole point is I want to know where do I get near? Okay, now, this one, we're just going to have an answer. Okay, but we're going to use a table. Okay, so let me show you how the table works. And then I want to show you the graphical way. That's what I wanted the dry erase pens for, is the graphical way. And then I'll show you the algebraic way, and the algebraic way is super friendly. Okay, but the table and the graph, they're a little weird. Okay, so I'm going to make my table the way I normally do tables, which is up and down. The book likes to do sideways tables. So if you see a sideways table like this in the textbook, feel free to do a sideways table or feel free to do your normal table. I think they save space in the book. I think that's the problem. Okay, so the first thing I want to do is I want to get near to 3. So what I'm going to do first is I'm going to pick the first integer or whole number near 3. So I'm going to pick 2. And then I'm going to try to get closer to 3. So I'm going to do 2.5. That's closer to 3. And sometimes it kind of helps if you look at a number line, especially with the negative. So if I'm at 3 and now I'm at 2, I'm picking X values that get closer and closer to 3. So closer to 3 would be 2.5. Closer to 3 would be 2.9. Closer to 3 would be 2.999 or 99. And then 2.9999. Okay, now that's from one side. So this answer right here is going to be the limit. And I like to teach you the two-sided limits right from the beginning, although technically that's not until section 2.2, 12.2 that they teach you this. But what I'm doing is I'm coming from the negative side or the left side of 3. Okay. So I'm going to have one answer for that. And then I might have a different answer if I'm coming from the other side of 3. So right now I'm just trying to go from one side to 3. I'm trying to get near 3. Okay, so I'm trying to get near 3, but I don't actually want to put 3 in my table because it doesn't matter where the y value for 3 actually is. Coincidentally, sometimes it will be the exact number answer, but sometimes it's not. Okay, so I'll show you how that works. I call that is Mr. Knox home, but I'll show you how to do that. Okay, so basically I'm just substituting this into 2x. So if I substitute that into 2x, I get 4. If I substitute 2.5 into 2x, I get 5. 2.9 would be 5.8. So I'm basically just substituting these numbers in here. And I'm going to show you a graphing calculator way to do this as well. But I picked something straightforward just so we could start to see it. Okay, so 2.9. So, where did I put my phone? Oh, my phone's over there. Okay, let me grab my phone. Okay. Okay. So 2.9 times 2, 2.98. I'm sure somebody can figure this out for me, but it's okay. Okay, so let's see. Where's my calculator? Calculator. Okay, so this is 2.99 times 2, which is 5.98. Oh, this is a perfect example, actually. I just made this one up, but I kind of like this one. So 2.99 times 2 is 5.9998. So put in the comments, or you can say it out loud, which is, what do you think this is getting near? Yeah, it's getting near 6. So 6 is called the limit. Okay, so now as I keep picking numbers closer and closer to 3, I'm going to get closer and closer to which number. So limits are about what are you getting close to. So in this case, the answer is 6. Now, that's a one-sided limit. Okay, I'll call this a one-sided limit, which technically is section 12.2. But it helps me to describe limits if I talk to you about the sides. Now, I like to make 2 tables, the left side and the right side. The way the book does it is they make a table where they have the missing gap in the middle, and I'll also show you how to use those. But to me, this way makes more sense. Okay, now if I'm at 3, I'm trying to get towards 3. What's the first integer on the right side of 3? 4. Okay, so 4. And now I'm at 4, but I need to get closer to 3. So I usually go half first. So that's what? Oh, that's 3.5. And what's closer? What's closer to 3? Yeah, 3.1. Sounds good. Then maybe 3.01, 3.00001, right? Okay, and then I'm substituting these into the equation. 8, 7, 6.2, 6.02, 6.0002. Okay, now this is near 3, but from the positive side. So the way that looks is x approaches 3 from the positive side. You put the little plus after the 3. Okay, and then 2x is your equation. And what does that look like it's getting near? What do you think? Where's that getting near? Yeah, 6 as well, exactly. Now, if both of the answers are 6, then the overall limit is 6. So really you do 2 sides. Now, this is the way that makes the most sense to me. So to me, if I was making my own table, this is the work that I would show. Okay, so this is the work that normally you want to show if you're trying to figure it out from a table. Okay, and this is in calculus as well. This is finding the limits with tables in calculus. Okay, let me just show you how the book does it because they set it up for you. Okay, and they draw a little XY chart like this. So let me show you what it looks like so you could see. And they kind of already dive right in to getting close. So I like to pick the whole number and then half and then closer. They kind of just go like immediately really close. So let me show you how they write it. Okay, so this is a 3, and then they put a question mark, but it's not really that they want to know what it is at 3. They just want to know what it's getting close to at 3. Okay, and then it looks like they have 3 on each side. Okay, so they have 3 on each side, and they picked close numbers. So here they picked 2.999, here they picked 2.99, and here they picked 2.9. So you could see they got real close to it real fast. I should make sure that my settings on my computer, I'm going to make sure the settings on my computer are, not make sure, I'm going to change them to send in 720p so that people can see this more clearly when we're on, when I save it to YouTube later. Okay, so let me go back to this. Okay. Okay, so what do you think they put on the other side? Patrick, if they're different, then there's no limit. That means they don't match. Yeah, so 3.1 is on the other side. Now 3.1 is farther away, right? So 3.1 is like that. And kind of I think of it as this way. The way they do the tables in the book you're coming in towards 3. So the next one would be exactly 3.01, and this would be 3.001. Okay, now if when we used to have tests on this, because I know you guys aren't having tests this year, I like my tables better because it kind of gets me into it. Their tables are the way they are, and that's okay. Okay, so what would this be? This would be what, 5.8, substituting that point in. This would be 5.98. This would be 5.998. So what do these look like they're going towards? Looks like they're going towards 6, right? And then these, but start writing from the outside. So the kind of the red is different. So this is 6.2, and then I'm going 6.02, and then I'm going 6.002. And look at what you're going towards. And you're going towards 6, which is in the middle. I don't really like the way they put this because it's a coincidence that when you substitute 3 in, it's 6. That's only because it's a continuous function, but it's actually not how limits are supposed to work. So the real short, beautiful way is you just plug in the number, and I'll show you that way as well. But it actually kind of takes away from what a limit really means. A limit really means is you're substituting in 2.999999999, and you're asking what the y value is close to. Okay. Okay, so that's the basic idea. That's how you do the ones with the tables. Let me show you how to do the ones with the tables on the calculator. Okay, because I don't think you're going to want to be plugging these in one by one. Yeah, I mean, you could. You could plug them in one by one, but let me show you how to do it on the calculator. It's kind of nice. So let me just show you the calculator to make the tables. Just to save you some time. Okay, so calculators to make tables. What you're gonna start with, and then I'm gonna show you on the other one, but let's write it down first. Is you're gonna go to, so step 1. Okay, is you're gonna go to table set, which is on the top row. Okay, and I'll show you how to do that later. Number 2 is you're going to change the independent variable to ask, and the dependent variable, you're going to have auto, and table start is irrelevant when you get there, okay? But we're just writing this out first. And delta table is also irrelevant. Okay, so that's for auto, but you don't need that for ask. Okay, and then you type y1 equals your equation. And then you're going to hit, and then we're going to go to this so you can find it. You're going to hit second table, which is on the top row, all the way to the right side. And then you type in the X values you want. Okay, so write that down. Write that down, and then I'll show you when we go to the table. Yeah, and when you're picking your own values for the I want to be close, then I picked like 3.0001. Somebody put in the message 3.0001. In the book, they're just kind of going 0.1 away, 0.01 away, 0.001 away. That's just what their technique is. But that's not what I do. I kind of just choose my own and kind of get there faster if I can. Okay, so if you want, you guys can be, you might, because I'm changing screens. So you make sure you write all these 5 things down so that you could see on the screen how that's going to work. Hey, Annabelle. See you. Annabelle, I don't know if you were here before and then you left. Annabelle, did you get cut out and then you came back, or did you just come now? Good question. Okay, Annabelle, I'm going to keep it on this screen so you could look at this. Okay, so you can look at this while I'm answering Austin's question. Okay, so Austin's question is, can you just pick one number that's close by? And the answer is that's not the point. The point is you need to be going towards it. So you kind of have to start a little bit away and then go towards it. So you got to pick at least 3 numbers on the left and at least 3 numbers on the right. In our problems, though, they pick them for you. You will not have to pick them, but I want you to know why they're picking them. Okay? So I want you to know why they're picking them. Okay, so remember that in this table, okay, I pick the numbers, but then on the left side here is the way the book picked the numbers. Okay, so I'm a little bit more wild than the book. The book has, you know, exactly 0.01 away and exactly 0.001 away. But the idea is you want to see as you're approaching the X's, what's happening to the Y's. And it could be that the Y's are just like flipping back and forth. Maybe you're getting 1, 0, -1, 1, 0, -1, or -0.099 and then 0 and then 0.99. And then, you know, they're going all over the place and you can't really tell if you only have one number. So you have to definitely pick more than one. Okay, so those are good questions. So I'm glad you guys are here. Okay, so I'm going to go to my other screen. Okay, and then you'll be able to go back to the screen to figure out where to go on the calculator if you need to. Okay, but I'm going to change to the calculator right now. Well, let's make up a problem. So let me make up a problem. So let's say we have the limit as X approaches, let's say -2. And the equation is X squared. Let's do X cubed plus 8 divided by X plus 2. Okay, so I'm going to type in to Y1 in my calculator. I'm going to type in X cubed plus 8 divided by X plus 2. And then I don't know if I need to put parentheses on the new calculator, so we'll see. But I'm going to take a picture of this. And what are we approaching? -2. Okay, and often the one they're checking is where it's undefined. But the point is, you don't really care about what X value when you substitute in -2. You don't really care about that value. You're wanting to know close to -2. But sometimes, coincidentally, it's the same answer. Okay, so let me go to my other screen. Let's see, my other screen would be, oh, right here, Wabbit Emu. Okay, so I'm going to follow the steps I gave you. So the first thing I do is I go to table set. It's on the top row. Mine's in blue. Okay, so mine, I'm going to show you where all the pieces are of what I'm doing. Okay, so what I'm going to be doing is this one, table set, to set up my table the way I want it to work. I'm going to also go to table later. That's step 3. And I have to go to Y equals, which is right here. And then this one, table set, is the top. I'm not really going to the window button. And then this table button. Those are going to be the things that I need to do. This is very helpful in general, is if you want a table of values, to just use the table and then type in the numbers and it gives you a table. So this works in lots of situations and not just with limits. Okay. So the first thing I said for you to do is you go to table set. So hit second table set on your calculator. And I said that the top 2 are irrelevant. So table start, change in table, that's a little delta. Doesn't matter unless you want it to automatically give you values, but that doesn't help you very much with limits. So we're going to change the independent one to ask. What that means, it's going to ask you, what do you want for your X value? And then it will automatically find the Y value for you. Okay, so that's a setup. Now, once I set that up on my calculator, it'll stay like that forever. On my tablet one, I'm not sure. But on your own calculator, you really only have to do this one time. Okay. The second thing I put on the list was I need to put, I don't know, what's the next thing I put on the list? Okay, so the next thing I put on the list, well, you have to get out of here. So I'm hitting second quick to get out. Okay, and then usually what I do is I do the Y equals equation next. Yeah. Because I'm thinking, is that what I put next? Okay, so the Y equals equation, and that was what? X to the 3rd power. Oops, my plus isn't up there. Plus 8 divided by, okay, so this is exactly how I wrote it, right? X cubed plus 8 divided by X plus 2. Okay, so you're typing the equation in. And if you were trying to like guess and check solve an equation, you could put the left side as y1 and the right side as y2, and then you could type all the answers in. For the SAT, it's kind of fun. There's some stuff we could do for the SAT. Okay, so what we're going to do from here is we're going to hit second and then the table button, which is on the far right. So you're going to hit second table. Now, did you see it's blank? It's blank because I haven't put any X's in yet. Now, let me write on this for a second. What were we trying to approach? So let me draw a little line here. You know how we were trying to approach, oops. We were trying to approach -2. So what's near -2? So I like I told you, I like to pick the integer first far away, and then I go half, and then I get really close. So what's the mark that I just put? Anyone can tell me the mark I just put? I put one integer away. Yeah, -3. Okay, so -3, and then what's closer than -3? So what's in the middle? Exactly. Okay, so you guys are doing good. So -2.5. Now I'm trying to get towards -2. So what about a little bit closer to -2? -2.01. That sounds good. And then maybe let's just do one more. Let's do -2.0001. Like add a bunch of O's. Okay, so those will be the numbers that we're going to type in for the left-hand side. That's the left side of -2. So that's going to give me a limit as X. It really doesn't like me being too close to the side. Limit X approaches to -2 from the negative side. And I can zoom in on that so you guys can see that. Okay, so that's going to be my X part of my table. And then I need to find the Y part of my table. So that's my X, and then this will be my Y. Okay, and then this, I put the equation here. Or sometimes people just put f of X if they don't feel like writing the equation. And then you'll get the answer here. Okay, and then separately, you're going to need to look at the right side. So the right side of -2. And often you get the same answer, but you don't always get the same answer. Okay, so I agree. Good, you answered the question before I checked. Okay, so on the other side, I'm going to do -1. And then what's halfway in the middle? -1.5, exactly. And then closer would be what? -1. How do I get closer to -2? Yeah, -1.9. And then maybe -1.999. Okay, so you kind of get the idea, but you don't have to pick your own numbers on the homework. They pick them for you. But it kind of helps you make sense. Okay, so I'm going to hit save on this. So those are going to go away, but let's type them in. So what I do is I just type them in right here. So we said -3, and then it gives me the Y value for -3. And then -2.5, it gives me the Y value for -2.5. -2.0 or 2.1, you guys said. -2.01. Okay, how about -2.00001? Sometimes I just get all exaggerated and I'm using a table. Now it looks like that's actually 12, but if I go over to 12, that's actually 12.000006. Okay, so what do we think the left-hand limit? That was the left hand, right? So what do we think the left-hand limit is? What does it look like it's going towards? Exactly. So this one, this table right here, if you wrote that on your paper from your calculator, you would basically write limit as X approaches -2. Now, was I on the left side or the right side? I was on the left side, so that's that negative of f of X, just because I'm too lazy to write the equation. I believe that that's 12. Now, if there's no sides, it means both sides. So if that little negative was missing, it means you need to check both sides. Okay, so then we'll check the other side. Okay, so the other side, I need to pick different numbers, right? So I like to make a brand new table. You can clear these out. You can't clear them out. You have to delete. So you could delete them. I'm hitting delete, or you could type over them. Okay, so on the other side, we said a -1. We said -1.5, -1.1, -1.001. And, oh, wait. Oh, that's funny. Those weren't my numbers. You guys, doesn't it look like it's approaching 7? Okay, so if this one was approaching 7, and then the other one was approaching 12, you would get no limit. And when we do it graphical, the picture of that is like you're trying to go to Mr. Knox's room, because his door is right next to mine, so I always use his room, and a lot of students know where that is. So it's like you said to your friend, meet me at Mr. Knox's room. And then you went to E12, and then the other person went to E7. So you didn't get to the same location. So there's no limit. It's not, Sabrina, it's not. That's why I made a mistake. But I just wanted to tell you, if I got this answer, right? I'm like, oh, wait, I went to 7, but my friend went to 12. So that's when there's no limit, which is the question from earlier. But yes, I made an error. Okay, so because I'm not looking at it, right? Okay, so really -1.9 was next. Is that right? And then -1.999. Okay, so are we both going to Mr. Knox's room? Yeah, we're both trying to get to eat. We're trying to both get to 12, right? Okay, so we're meeting outside. Okay, so this is 1.99999. Now you'll notice it looks like it's a 2, but it's not. It's just because it rounded for the screen on the calculator. So it didn't really plug in -2. In fact, if I actually plugged in -2, it gives me an error because it's undefined. Okay, so those aren't really -2. That's -1.99999 and -1.9999. And then you do whatever we chose, and you pick the ones you pick, and then you write the matching numbers. Okay, so I feel like so this answer here would be, let me take a picture of this so we could write it down. So this would be limit. This is limit as x approaches -2, but from the positive side of f of x. And that also looks like it's 12. But imagine it was 7. It's like you and your friend didn't go to the same spot. And then what I call it is for limits, it doesn't matter if Mr. Knox is really there. So you might have a situation like the situation I just got is something like this, picture-wise, okay? So I'm headed towards 12. Okay, so this is 12. This x value is -2. And then my other person is also heading towards the value 12. But it could be an open circle. In this case, it is. So I call that Mr. Knox. Mr. Knox isn't home. So it doesn't matter. Well, technically in his classroom. But it doesn't matter whether this is a closed dot or an open dot, because limits are what are you going towards, not where did you end up. Yes, point discontinuity is the official term in calculus. Okay. Okay, so were the limits the same on both sides? Yes, so that would be the overall limit. Okay, so let's go back to this. So that kind of gives you an idea of what limits mean. Okay, so let me show you a picture. I'm going to change to graph paper here. And this is the part I really wanted to do on the dry erase board, but the fact that it's backwards and it's not clear, I'll need to find another solution to that. So we'll see. Maybe I'll make a stand at some point. But this is really the only lesson that we ever would need that. So I think I just use a bunch of arrows. Okay. I'm going to have you draw a picture. And you have to draw the picture that matches mine. Okay? Okay, so I'm going to zoom in so you could see the squares. Okay, so over here at 3. Okay, so over at 3 squares, put an open dot at 2. At the y value of 2. Okay, I'm going to have you put another point at 6. And 6 is going to be the y value of 5. I'm going to connect these with a parabola. It's going to hit the x-axis over here at 10 and go down. Okay, so at 1, you're going to have a closed dot at 2. I may have an open dot there. So I'm going to have an open dot here. And we'll have a little loop to connect those two. Closed dot up here at 5. That's 4. And I'm leveling off over there at 1. Okay, so draw that picture for me, okay? So make sure you draw that picture accurately. Let me zoom in so you can see my picture. Okay, so zoom in accurately because I want to teach you how to do the graphical ones. The graphical ones are the weirdest ones. Oh, my phone battery is at 5%. And I'm connected on my tablet. I'm connected on everything here. Otherwise, we're off online. Online would be totally off. Patrick, oh no, my picture's too complicated. Or, oh no, my phone, if I have no batteries, we're all disconnected with my 5%. Yeah, 5% sucks, huh? Okay, but it looks like on my tablet, I'm at 72%. Oh, how am I on my computer? I don't think I have my computer cord. My computer is, 16 minutes. Oh, dang. Okay, guys, make sure you do that picture. Score. Okay, computer cord. Hey, lucky my phone was on 5%. Okay, there we go. Okay, so is that enough time for you guys to do your picture? Okay. So this is the part where I really wanted it on the dry erase board because I use my hands. But we'll see. Okay. How am I going to do this? Okay. Okay, I'm going to put a little key up here, okay? So my right hand, or let me make that a little skinnier. Okay. My right hand is going to be yellow. Okay, so every time I'm doing my right hand, it's going to be yellow. And you physically need to use your hands, okay? That's my trick of limits, is you have to use your actual physical hands. Okay? So right hand is going to be yellow, left hand is going to be blue. Okay? So you have to pretend those are my fingers pointing, my right hand finger and my left hand finger. Okay. So the first one I'm going to show you is 1. Okay, 1 will help you understand it the most. Okay, so I'm going to write over here, limit. So this is like part A. Okay, so it says limit as x approaches 1. Now, in the first section that you're learning, this x approaches 1. I don't think that you guys could. Yeah, that dry erase board is going to be too blurry. Okay, so as x approaches 1, if they don't put a side, this means, okay, so let's put this under it. It means both sides. Okay, so let me show you what it means. It means find the limit as x approaches 1 from the left side. and find the limit as x approaches 1 from the right side. And then we'll just call this g of x or f of x, whatever function we want to call it. We'll call it g of x. So this whole picture is g of x. Okay, so this is the limit of g of x. So if I ever want the limit as it approaches 1, I need both sides. And that's why they really want to teach you with the table. Okay, so what I'm going to do is I'm going to use my yellow highlighter to pick an x value to the left of 1. Okay, so I'm working on this one right here. So I'm going to highlight this one. I'm going to work on this one right here, and then I'm going to put the answer. And I'm going to use my yellow highlighter on my physical graph. Now, you need to use your actual physical left hand. So grab your left hand. I don't know if this looks like my right hand to you, but this is my left hand. Okay, so if you don't know which one's which, make an L. Like, to me, that looks like an L. So looks like an L to myself. If it looks like an L, then that's your left hand. Okay, so 1 negative means 0.5. So if I go over here to 0.5, where's my y value? Okay, my y value is right here. Okay, so I don't really like that being a thing. So my y value is right here. Oh, really? Okay, there we go. I was on eraser back then. Okay, so I'm right here. I just don't like that it's so big. Oh, because it's a highlighter. Oh, it doesn't like to do a dot. Can I make my highlighter skinnier? Okay, that's annoying. Okay, I'm gonna make it yellow. We'll make it yellow. It'll look like this. Okay, so here's my yellow. So my yellow is right here. That's 0.5. And then where's 0.9? 0.9 is like right here, right? And then 0.99999. Okay, so as I'm going this way, okay, so I'm gonna draw a little arrow. So I'm headed towards x equals 1. I'm going towards x equals 1. What y value am I going towards? That's funny. Okay, you guys are right. I'm gonna change this. Okay, you guys, I'm not very good with my right and my left. Okay, so you're telling me that was the left hand. Hold on. There we go. I'm changing colors. Okay, should have been watching your comments. Okay, so you're right. I was doing the wrong hand. Okay, so what does it look like it's approaching? It looks like it's approaching 5. So that's the answer to this one, 5. Now, the answer to a limit is a y value. Okay, the answer to a limit is always a y value. Now, if you're telling your friend, hey, we're going to meet at Mr. Knox's room, like go to, you know, Mr. Knox, which is 1. The only problem is what happens with my blue. So I like I said, I don't really like my blue. I'll do a light blue over here. Okay, so what? 2 is right here, right? That's x equals 2 on the graph. And then x equals 1.5 on the graph is like right here. And then x equals 1.1 on the graph is here. And then I'm getting closer and closer and closer. So what y value am I getting closer to on this side? So what y value am I getting closer to on that side? And again, right hand on the physical graph, you want to trace it with your finger. 2, exactly. Okay, so that's 2. So, except hold on. You guys, I put the answer in the wrong spot. Okay, so erase that. This was this answer, right? This was 5. Okay, and then back to this one, which was from the right side. And that was, what's that answer? You guys said that was 2. Okay, now, did you and your friend meet up? No. So this means no limit because they don't match. Okay, so here the answer would be no limit. Okay, and some people call it no limit. And then some people, which is the more normal name, is does not exist. The limit does not exist. Okay, so no limit, or you could put DNE. People put DNE all the time. DNE is the other official way to call that. Okay, so where's my other weird spot? So we'll do B. Now, the individual left-hand and right-hand limits exist, and they are 5 and 2, but the overall limit as x approaches 1 does not exist. Okay, so x equals 3, I agree. So let's look at x equals 3. So limit as x approaches 3 of g of x. Now, to really find this answer, I'm going to be looking at the two separate ones. Okay, so I really want to find the limit as x approaches 3 from the left side. Okay, so this means check both sides. And the one-sided limits are actually the next lesson. But to me, I can't do two sides if I don't do individual sides. Like I do the left side and the right side at the same time. Okay, so for me to find 3, I want to check the left, I want to check the right. Okay, so I'm going to erase my other colors here. Okay, so I'm going to erase my other colors. This was a closed dot at 5, right? Like this. Okay. Okay, and let's see if I can be on the right color this time. So left side was yellow. So I'm using orange. Okay, so what's the left side of 3? So 2.5 or 2 is right here. 2.5, 2.9, 2.999, 2.99999. So use your left side to trace where I'm writing in yellow, orange. Okay, so I mean, and sometimes I'll go back a little farther, but basically I'm going towards this location. So you and your friend are saying, let's meet at 3. We're meeting at Mr. Knox's room. Where did you go? Did you go to Y2? Did you go to Y5? Did you go to Y4? Did you go to Y1? Where did you go? Okay, so for the left side, what did you guys say? Any answers? So on the left side, what Y value, it is my arrow looking like it's touching? 2, exactly. So that's 2. Now, what about the right side? Okay, so the right side, so change and use your right hand. And you know what? I think this is probably why in my tables, I don't start too close. Because in my graphs, if I start too close, I can't see anything. So I'm going to do my light blue. So what's the biggest integer closest to 3? 4. So I go to 4, whatever, this blue value right here. So 4 comma, 3.5. And then I'm like 3.5. And then, so I'm using my finger. And if you see me in class, I basically am tracing this little blue spot and I'm tracing my finger following this blue and aiming towards x equals 3. Now, what Y value does that approach? So what Y value does my blue one approach? 2, exactly. So my left hand approaches the same spot as my right hand. Okay, so look at the picture of me, if you can, for a minute. The picture of me with me in my blue shirt. Okay, so this side is going towards this. We'll make it my eye. Okay, so the open dot will be my eye. So this one's going this way towards my eye. This one's going this way towards my eye, and we're both hitting Y equals 2. Now, is my eye open or closed? That's kind of cool. Okay, it doesn't matter. Okay, so that's is Mr. Knox's home. So is my eye open? Is it an open dot or is my eye closed? Closed dot? My friend and I are still going to the same spot. That's the limit. Okay, so this overall limit is 2 because these two match. Any questions so far? It's a little odd. It's the trickiest part of calculus, actually, is these limits. The graphical limits are the trickiest part. It's really about the hands, though. Okay, so let's try another one. Let's try C. I want to know what the limit as x approaches 6 of g of x is. Oh, and before we do that, I want to tell you something interesting is even if I added a dot up here at 3.6, look at me, I just put a dot at 3.6. Hey, Mr. Knox is in somebody else's classroom, not his own. You and your friend are still going towards the same spot. So there's still a limit, even if Mr. Knox is way up here. Okay, the limit is where you're going towards. So I don't really care about the number 3. I don't really care about 3 itself. I care about 3.0001, 2.99999. That's what I care about. Okay. Anyway, so it doesn't matter if this dot was up here or not up here. The limit would still be 2 and not 6 or whatever that y value is. Okay, so as x approaches 6. So use your right hand or use your left hand. Let's start with the left hand. So use your left hand and try to get 6 from the negative side. So to me, the left and right hand limits is the work to get the overall limit. So I find it very difficult that the book doesn't teach you right and left hand limits until 2.2. So to me, my brain's out of order on these. Yeah, what do you think? Do you think he's right? Do you feel like, and let me change my colorings here. Okay, so I'm using my yellow and I'm tracing the graph with my hand on the left-hand side of 6. And where am I going towards? What y value? Okay, so you guys agree with this 5? So that would be this one. Okay, and that's my yellow, not my blue. Okay, so that's my yellow. Okay, and then the limit as x approaches 6, that's the other side, right? So I'm coming from here. So imagine these highlighters as my hands. And then where am I going towards? So where's my right side limit going? Also 5, I agree. So then what's my overall limit? 5, exactly. Now, is Mr. Knox home in this one? Yes, Mr. Knox is home, but it doesn't matter if Mr. Knox is home. Okay, but most of our graphs in math do not have open circles. Most of them have closed circles. So most of our shapes, we can use a shortcut and just say, well, you know what? If we're meeting at Mr. Knox's room, how about we just find out where Mr. Knox's room is? And then we'll say, oh, that's where we're going towards. So it's only with open circles or asymptotes or weird things that you can't just say, well, why don't I just substitute the number into the equation, find out where Mr. Knox is, and that's where we're both going. And that's the direct substitution method that we're going to use. That's super easy. You're going to love it, except then you have to remember some of your tricks. So direct substitution, it's like kind of an oxymoron, is that I don't care where Mr. Knox is. But if Mr. Knox is in his room, wouldn't it be easier just to call him and say, hey, where are you? And then we'll meet there. So, but technically, we're just supposed to get close to it, and it doesn't really matter if it's an open circle or a closed circle. Okay, so let's just do one more, and just do this one with both hands. We'll do 2 more. X approaches 10. Okay, and I'm just going to put both hands. So you trace it with both hands, and then E is limit as x approaches 0 of g of x. And then I want to do the infinities as well. But I don't have too much time yet left, so I want to make sure I show you the direct substitution also. Okay, so what do you think? Both hands. So both hands. Okay, so right here where my eye is, this is 10. Okay, and I want to go towards 10 from one side and towards 10 from the other side. And then you have to tell me what y value both your hands go towards. What do you think? If you're going towards 10, yes, the y value both go towards would be 0. Now, if one of your hands goes to one thing, like to my mouth, and then the other one goes to my eye, well, that's no limit. Okay, you are not going to the same spot. Okay, now what about x approaches 0? So here's my y-axis. Okay, so here's my y-axis. So I've got to be approaching it from here and approaching it from here. My y-axis, I need another hand. Okay, so what's that one? 4, I agree. Now you guys who are answering, have you done these limits before? Because this seems a little too easy for you guys. So this is supposed to be really complicated. Cool. Okay, that means we're good. That means we're going at the right pace and I'm not going too fast. Okay, good. Okay, I think the one person who said, what did you say? You said it was a point discontinuity? Okay, you definitely saw it before. Okay, cool. Okay, so you kind of got the hang of it. Okay, let me just show you the infinities. And then the direct substitution is pretty friendly. Okay, so F, and I don't think F is in your homework and G is in your homework, but I want to show you because we're here with the graph. So limit as x approaches infinity of g of x. Okay, and then limit as x approaches negative infinity of g of x. Okay, and then we're going to have answers for this. Now, these don't have both hands. These are just one hand. So this one is you need to go as far right as you can. So right forever. Okay, so right forever. So if you go right forever on this graph, follow the graph. Okay, and so you kind of want to start, maybe you could start at 10, you could start, because I'm going to do this one in red. So I'm going to do positive infinity in red. So I'm going to go over here, I'm at like 10, and then I'm at 11, 12, 13, 14, 15, 16. So where is my red arrow going? Anyone have an idea where your red arrow is going? Yes, negative infinity, I agree. So that's the answer for this one. Negative infinity. Okay, now what about let me change colors here. Let's do green. That's my favorite color, actually. So let's do green. What if I'm approaching negative infinity? So negative infinity, I'm like over here at -3, -4, -5, -6. Okay, so what's happening to my y value? Yes, except mine is a different spot. So here, look at mine. So I agree with your idea, and you might have drawn it so it approaches 2. Yeah, for me, it's 1. But make your answer whatever you made yours. I leveled mine off specifically at 1. But you might have leveled yours off at 2, so then call it 2. Okay, so it's whatever you leveled it off at. But for me, I leveled it off at 1. And what did that just make then? What's G from the other day? If you're approaching infinity, but you approach a number. So you go x approaches infinity, you get a number, what does that make it? An asymptote, exactly. That's a horizontal asymptote at y equals at 1, and that's a left hand. I know the right and the left might not match. Anyway, so that's how those work. So they're kind of cool. You're going to have to review graphing piecewise functions. Okay, so look in your notes from semester 1, because what you're going to have is you're going to have potentially something that looks like this, where you have to draw your own. Okay, so and some of the homework looks like this. So at 3, there's this parabola up 5. Okay, that's a bad parabola. Let's go negative in the front of that one. So it's a facing down parabola. That's not that great of one either. And it's like here, and it is this side. So I have this parabola to the left of 3. Open circle, and then y equals 2x, right? Y equals 2x is like, let me change colors on that one. But you'll want to review this. And then 0, 0, slopes 2, 2, 2, 2, right? I can do this line. And then over here at 3, it's a closed circle to the right. Okay, so if I look at my green and my red, and then they say, what's the limit as x approaches infinity? I mean, limit as x approaches 3 of g of x. They want you to graph it and then decide. Now, my right hand was blue, right? So my right hand approaches the y value of 6. But my left hand approaches -4. So what's the limit if one is approaching 6 and one is approaching -4? Okay, so one is approaching, and then we'll write this for both. Limit, we'll put but x approaches 3 from the positive side of g of x. So if you look at this picture, if I approach 3 from the negative side, I'm down here at -5, right? That's my y value. That's for the green one. That's for my my yellow highlighter. But my blue highlighter, the limit from the right side looks like it's 6. So the limit from the right side is 6. So if the y values don't match, I'm like, this one's going this way, and then this one's going this way, and they don't match. So what do you call it? Yes, does not exist. So this is, you either write does not exist like that. That's the official way. Okay, but if you put no limit for now, that kind of makes sense. because you're just brand new learning it. Does not exist is a little more official. Yeah, no limit exactly does not exist. Either one, hey, they don't match, so you don't get to pick one, you don't average them, you don't write both of them. Okay, so let me show you direct substitution, which is the best one. Direct substitution is the most amazing one. Okay, so direct substitution is going to take us the 5 minutes I have left, or maybe we'll do 10 minutes because we started a little late. Okay, so direct substitution. So direct substitution is, if there's no holes, find out where Mr. Knox is, and that's what you're approaching. You're going towards Mr. Knox because you're going towards his classroom. So direct substitution, you just plug in the X value. And that's it. Seriously, you just plug in the X value. So let me show you the first one. You know how we had limit as X approaches 3 of 2X? You just physically stick the 2 in, the 3 in, and then you get 6. Which is the same as F of 3. So it's very odd. You're like, hey, why didn't you just show me that at the beginning? Because that's a coincidence. Mr. Knox is in his classroom for most equations. If you think of a parabola, just an ordinary regular parabola. Say you had an ordinary regular parabola, x squared plus 5. Ordinary regular parabola. Okay, so let me just kind of draw a sketch of this for you. You're up here at 5, you have this parabola, and here's 0. And you're like, oh, where are we meeting? Well, we're meeting in Mr. Knox's room. Left side, right side. Okay, but there's no open circles. So just find out where Mr. Knox is, substitute 0 in, and you're going to find out where you're going. Technically, we're plugging in 0.1, 0.01, 0.01, 0.00001, but fortunately, for most functions we have that are continuous with no holes or asymptotes or things, it's just the answer if you plug in. So this is actually 4 problems. This is 4 problems in your homework, 45 through 60, 45 through 63. Direct substitution. You just plug that, you plug it in, and you get the answer. No graph. This is not needed. You don't need to graph on the ones that say direct substitution. And they do say direct substitution on them. They do. They say find the limit by finding direct substitution. But the reason they don't show you that at the beginning is you're like, well, I'll just always plug in. But let's look at this last one. If I actually had plugged in this right here, let me highlight this. See this equal sign? If I plugged in, I would have gotten 6, which is where's Mr. Knox. But in this one, for the red graph, Mr. Knox is right there, right here at 6. So Mr. Knox is at 6, but your friend went somewhere else, and so there was no limit. So despite Mr. Knox being in his classroom, you went to the right place perhaps, but the other person went to the wrong place, so there's still no limit. So that's why we can't just substitute in. So in that review of piecewise, I put review. That's not complete review. I just meant review of piecewise. So you should review piecewise from, I think, chapter 1. Okay, but limits weren't chapter 1. Okay, so let me show you the only thing that at the moment is going to make these difficult. All of them are normal. And I'll show you how to do the limits where you get weird, cool stuff the next time we do this. I think that's going to be Sunday. Limit as x approaches pi over 2. Let's say pi over 6 of sine of 7x minus cosine of 3x. So this is where people get trouble on the test because they're like, but Miss Nichols, I forgot all my trig values. Can I plug 3 into the top of the piecewise? I can. So let me go back up here. I can plug 3 into the top of the piecewise to get this value. But that's because of the same idea, right? Is if I plug in 2.999999999, isn't it really the same as plugging in 3? Right? So plugging in 2.999 is like plugging in 3. So you're like, okay, that one approaches 6. So you can when you're doing the right and the left. But remember, the idea is you're getting closer to it. But definitely when I show you the limits from the right and from the left, is if I wrote, I can write this over here. So if I wrote limit as x approaches 3 from the positive side, I would say, oh, I want to use the 2x equation. And if I was doing the limit as x approaches 3 from the negative side, I would use the negative x squared plus 5 equation. Oh, so that was the wrong one. Okay, so if I substitute in 3, I get negative 9 plus 5, which is negative 4. Oh, you guys, I graphed that one wrong. This is negative 4. Okay, and then this one, if I substitute this in, it's 2 times 3, which is 6. So on left hand and right hand limits, you will also be able to use the direct substitution method. So we're gonna kind of put this. This is direct substitution, which is not what they're having you do for the graphs. Okay, because in calculus, there's only 3 concepts. There's limits, derivatives, and antiderivatives, but you have to learn how to do it tables, graphs, and algebraically. Okay, so we need you to do it in all of those different ways. Okay, so algebraic way is the way we're most comfortable with. Okay, so let's do this last question. Direct substitution. You're going to substitute this into both. So this would be sine of 7 pi over 6 minus the cosine of 3 pi over 6. Okay, so I like to do degrees. So to me, that's 210. And this is cosine of pi over 2 if I reduce, right? Divided by 3, divided by 3. So that's the cosine of 90. And then we have to remember how to do these. So different people do them different ways. I don't use the unit circle. I use a triangle. So 210 is over here. Reference angle is 30, right? 210 minus 180 is 30. And then across from the 30 is a 1. Across from the 60 is a radical 3. And across from the 90 is a 2. Left is negative. Down is negative. Hypotenuse is positive. And sine is what? Opposite over hypotenuse. So opposite over hypotenuse would be negative 1 over 2. Minus cosine of 90. Okay, cosine of 90, I don't know how you guys do it, but I usually do it as a squiggle graph. I call it a squiggle graph. So here's my cosine graph. You can also do it X, Y, and R. Okay, but I whip out a cosine graph here. And then I know these are every 90. Something exciting happens. So cosine of 90 is right here. So cosine of 90 is 0. So negative a half. But you're going to want to review how you did it in the past. And you're going to want to review this. So let's put review now and in the week before calculus. Okay, the week before calculus, you're going to want to review not limits so much, is trig functions. You'll find that there's quizzes on trig functions. It's like find the sine of 210, find the sine of 7 pi over 6, and you're like, oh my gosh, I forgot that. So you're going to want to review that the week before school starts. Sounds good? Any questions? Let me just kind of look over the homework to see. There's a couple where they say use a graphing utility. So you can use a graphing utility or you can use the table. And then the piecewise ones, they want you to graph. There's only 2. Graph the piecewises yourself. Create a table of values. Okay, so this is all the stuff. No, not too much. Rarely do you need double angles and triple angles. Don't you need a cheat sheet in calculus? Well, not for the test though, right? So you're gonna have to memorize your facts. So you don't get a cheat sheet for the trig values. In IB, they give you 12 pages of formulas. But our IB classes, take the AP test too usually. So, yeah, so you don't get a cheat sheet in calculus on the test. Very rarely. At the end, maybe they give you one for the final exam. That doesn't help you on each individual test. Okay, I'm going to stop the video unless you guys have any more questions. And then I won't log off right away, but let me at least stop the video so the YouTube video stops. And then it doesn't seem too long. Stop recording.